Okay, you can all see my screen? All right, so now we're going to move on and learn how to convert from degree angle measure to radian angle measure and back and forth and figure out what radian measures are, right? The first thing you need to know if we're talking about radian angle measures is you go around a circle. The measure of the circumference, whoopsie daisy, I'm always doing that. The measure of the circumference. Does anybody remember the formula for circumference? C equals what? Anybody remember that?
C equals
2
260. Oh no, 270.
2 pi r, 2 pi times the radius length.
Oh, okay.
Right? Right? So circumference formula is 2 pi r. R is whatever the radius is. Okay? Now, we can have full circumferences or we can have parts of the circumference, right? Like an arc measure. And if you look down here, they're going to define a radian. We'll have to talk about this just a little bit. So a radian angle, you know, they're going to use theta. It's created by a rotation about point A using a radius of r, of the circle, okay? And the arc length. So not necessarily the full circumference, right? But an arc length S. If you look at the diagram, this thing could be a full circle, right? This is going to be slack. Okay? It's really slack. It's a horrible circle. But anyway, right, that S is just some part of the circumference, right? That's just called the arc length, okay? So theta, the angle measure here, right? Everybody see this angle measure theta, okay? We can work that out by taking S, the arc length, divided by R, the radius. Well, why is that? So let me ask you a question. Circumference equals 2 pi r, right? If I was to take this radian length, right, and lay it out, let me use red. That was supposed to be red. Take that radian length and lay it out around the circle, right? How many of them would fit in the circle? Around the circle, around that circumference. How many of them? How many of them?
2
pi of them.
2 pi r.
Right? If I took that radian length, like it was a string, right, and I went to wrap it around the circle, wouldn't there be 2 times pi radians all the way around the circle? Because that circumference is 2 pi times the radius, right? That means every circumference of the circle has 2 pi radiuses all the way around it. Okay? That's kind of key to know. But now, if we took this formula here, theta equals S over R, okay, and we're going to be using these formulas to solve for things, right? And I wanted to solve it for S, I could just multiply both sides by R, couldn't I? And so what do I get for the arc length? S equals what?
S equals
Theta times the radius, right? Okay.
Theta times R.
Yeah, so I could solve, like, we could start solving problems with these two formulas now, okay? So theta, this angle equals the arc length divided by the radius, right? But this arc length S is equal to that angle times the radius, okay? So let's look at an example here, see if we can clear some of this up. This could be a little bit confusing for kids. So example 1, part A, consider a full rotation. How many degrees is that, full rotation?
360.
360. But it's also 2 pi, isn't it? All the way around. 2 pi times the radius. And a counterclockwise.
2 pi 360 times 360.
Yeah. Well, let's take a look at this first part. So, A, what is the arc length S in terms of the radius? Okay. For full rotation. Well, we know full rotation is 360 degrees, right? They kind of already gave us the formula, right? So a full rotation, right? Wouldn't you agree that that equals the circumference? And what does circumference equal? C?
C equals 2 pi
2
r.
pi times the radius, right? So if our arc length is the full circumference, right, the S is 2 pi r, right? So we just say that S, our arc length, is 2 pi times the radius. That's like the simplest one, right? That's a full circumference. So the arc length goes all the way around, and so its length is 2 pi times r, all right? So let's look at part B. So based on the references above and our answer to part A, how many radians are there? So radian angle measures are there in one full rotation? Well, angle measure, theta equals S over R, doesn't it? Equals our arc length, S, divided by the radius.
R.
But from part A, what is our arc length equal to?
2. S equals 2 pi r.
So let's
theta
substitute.
must equal 2 pi.
2 pi R over R. We just substituted, didn't we?
R.
And so now what cancels?
The r.
And so what is theta equal to in one
Theta
full rotation?
equals 2 pi.
2 pi. So that angle, as we go all the way around, is equal to 2 pi, right?
What's that letter on the bottom? Was it 2 pi r over something?
R. It's this very same R. Okay. I just substituted, now I canceled them out. All right, so let's think about this. One full rotation. Equals, we know it's 360 degrees, right? But now we also know that it equals 2 pi radians. Right? So 360 degrees of an angle measure is equal to 2 pi in radian angle measures, right? So if we open that angle all the way around, its measured in radians is 2 pi of them. Make sense? Because remember I told you how many radiuses fit on the circumference? 2 pi. So the angle would be 2 pi radians. Does that make a little bit of sense to you maybe? All right. Let's go down to exercise 2. Maybe, hopefully, as we go along, this will clear things up for you, okay? And if you have a question, as always, ask, okay? So exercise 2, use the formula above to answer the following. A, determine the number of radians, right? That's our theta. It's going to be our angle measure, not in degrees, that the minute hand of a clock passes through. If it has a length, right, the arc length, S, of 5 inches. So the minute hand moves 5 inches. We don't know how big the clock is, right? And its tip travels, oh wait, let's see. Oh, okay, sorry. I misread that. The length of the minute hand is 5 inches. So isn't that our radius? Right? I misread that. And it actually travels a distance, right, of 13 inches. Wouldn't that be the arc length that it travels? And what do they want to know? Theta?
Yeah.
Okay, so up above,
So theta equals
S over R, right?
S over R. So theta equals 13 over 5.
Equals 13 over 5.
Simply divided
Right.
to
You end up with, you put that in your calculator, you get 2.6 radians.
yes.
It's the angle that the minute hand goes through. 2.6 radians. Does that make a little bit of sense? We're not in degrees now, it's in radians. Okay? Because the clock's a circle, right? Let's look at part B, a pendulum. You know what a pendulum is, right, guys?
Mm-hmm.
It's like if you have a string with a weight hanging on the end of it, you know, and it's hanging, and you give it a swing, it swings back and forth. Okay, that's a pendulum. Could a pendulum, does a pendulum like make part of a circle?
No,
Sure it could. You ever been on a swing set
Yeah.
as a kid and try to go all the way around?
it could, but
It could. We could think of it as part of a circle, couldn't we? let's kind of sketch a pendulum here. So here's a pendulum. There's a point where it's hooked to the ceiling or something like that, right? And maybe we start out with the pendulum and the weight out here like this, okay? And the pendulum kind of swings back and forth, doesn't it? Doesn't it kind of swing like this? Oh, let me just do better. Swings this way, right? And then comes back that way and goes back and forth. Can we not think of that as part of the circle? Like if it went all the way around? Right? And it says it swings through an angle of 0.55 radians. So our angle is inside here, right? 0.55 radians, right? We're not in degrees, right? And how long is the pendulum?
8 feet.
So 8 feet. Would that not be like our radius? Wouldn't that be the radius of the circle, the pendulum length? Okay. And this distance that it travels from here to here, wouldn't that be our arc length S? Like how far does it travel? All right, so now we need to set up something that S equals and find out how far.
Oh, X equals theta times R.
Yeah, right. So we know that, so theta, let's just get our variable, is 0.55 radians, yeah? And the radius equals 8. We want to solve for S. Okay, well, it's pretty simple, right? S equals theta times R. So S equals 0.55 times what? 8. Simple as that.
Times 8, which S equals 4.4.
So 4.4, what are the units in feet? So it travels in its swing an arc length of 4.4 feet. Okay. Did I lose anybody with this one? Please stop and ask me if I did. Okay. All right, let's go on to the next example, and then I'll give you a way to convert from radians to degrees and then back and forth. So on the next page, consider half of a full rotation around a circle. We know a full rotation is 2 pi, right? 360 or 2 pi, right? So let's just establish that again. So a full rotation, right? That equals 360 degrees, which we know also equals 2 pi radian angles measured, right? RAD, you can abbreviate. So what would be half of a rotation?
180.
Equals 180 degrees, but how many radians? What's half of 2 pi?
1.
1 what?
1 pi R.
Pi radians. 180 degrees is pi
So it's
radians.
Pi radian.
And that makes sense. If 360 degrees is equivalent to 2 pi radians, then 180 degrees has got to just be pi radians, right? We divide it by 2. Okay? So this is kind of key, right? The 180 degrees equaling pi radians. Knowing that will allow us to convert between radians and degrees. If every 100 degrees is pi radians, we can convert. Before we go to part B, let me give you a quick note here. Okay, let's go over to the notes page. Before they start this stuff, I want to use this 180 degrees equaling pi radians to show you some conversions. And then we'll go to part B. Okay? So let's talk about converting radians and degrees. We can do a couple of them pretty easily right now, right? 100, if you wanted to convert 360 degrees to radians, what would that be?
That would be,
We just did 2 pi of them, right?
yeah, 2.
And 180 degrees is how many radians?
That would be 360.
No, we just did. 180 degrees is pi radians, right?
pi radians.
So could we write a ratio here? A ratio of 180 degrees, right, to pi radians?
Yes,
Or we could flip the ratio around, right? Pi radians to degrees, 180 degrees, right? Now, if I was to multiply something by one of those, certain units might cancel out. You remember doing that stuff, okay? So to convert, we're going to have to multiply, you know, by one of these ratios that cancels the units we want gone and leaves the ones we have. The best way to show this is with an example, okay? So here's an example, right? I want you to convert, okay, 180 degrees to, we already know what it is, radians, okay? Well, let's take our 180 degrees, and we're going to multiply it by one of those ratios. And I want degrees to cancel and radians to stay, right? So won't I need degrees top and bottom of each other? Right?
yes,
So let's multiply by the second one. Pi radians to 180 degrees. Now units, just like numbers, will also cancel, right? So we have degrees that are top and bottom of each other. So these degrees cancel. And don't the 180s also cancel? And what am I left with?
pi,
Just pi what?
pi radians.
Pi radians, okay? That's one we already knew, but that was a simple conversion. Let's try one that's not quite 180, right? Let's try 120 degrees to radians. Okay, so let's take our 120 degrees, and I want degrees to cancel, so I need them top and bottom of each other, right? So I'm going to do pi radians to 180 degrees, okay? Degrees are top and bottom, so will they cancel?
Yes,
Okay, so let's start simplifying this, right? So I have 120 over 180. Well, let's get it in lowest terms fraction, right? Can we divide top and bottom by at least 10? And get 12 pi radians over 18. And the degrees are already gone, aren't they? Can I reduce 12 over 18 even more?
yeah, by 6.
Divide them both by 6, and what are we left with?
2/3 pi of pi radians.
2/3 pi radians, right? Or you might see it as 2 pi. I should write it as 2 pi over 3. That'll be more conventional. Let me just do this. We can do it as 2 pi over 3 radians. Let's do it that way. You see how you do that? So I just, what is 120 degrees in radians? I just multiply it by pi radians over 180 degrees, let things cancel, put it in lowest terms. So 120 degrees is equivalent to 2 pi over 3 radians. Let's go the other way. Let's take radians now and convert those to degrees, because you'll be able to do that, okay? So let's convert the following. Here's a separate, different example, because we're going the other way. So now let's convert the following. Let's start with a really simple example. Let's convert pi radians to degrees. Okay? So I'm going to start with my pi radians times, now I want radians to cancel and be left with degrees, right? So which of those two ratios up top am I going to multiply by?
Multiply by 180 over pi.
So I need radians in the bottom, right? So 180 degrees divided by pi radians, right?
And both
So
pi
our
radians cancel each other out.
radians cancel. Anything else cancel here?
Pi,
The pies, and as we already
that would
knew,
leave you with 180
right?
degrees.
So we just did the conversion for something we already kind of established, right? Let's try a different thing other than just pi radians. Let's try pi over 2 radians. So pi over 2 radians, 2 degrees. Okay, so let's start with our pi radians over 2, right? And we're going to multiply, so we want radius to cancel, right? So times 180 degrees over pi
I
radians.
would leave you both pi radians will cancel each other out.
They
leaving you with
cancel.
180 over 2,
So
which would leave you to 90 degrees.
okay, so pi over 2 radians is 90 degrees. You kind of getting the gist of that there? Right? Does that kind of make sense to you? I know that places up there using that unit conversion, right? Units will cancel if they're top and bottom of each other, right? Let me draw a quick sketch of the coordinate plane. Now that we know some different radian measures, right? So we know in degrees, right? Our coordinate plane, our angles look like this. This is 0 degrees. This is 90, right? And then what do we have?
180 degrees and 270 degrees.
Okay. And then back around, we're at 360, right? So let's look at the same thing, but in radians now. Okay? So same coordinate plane, but we're measuring our angle differently, right? We're still going to start over here at 0 to 0. Whoops. Good gravy. 0 radians. And our 90
You get 1/2 radians.
is actually, yeah, pi over 2 radians. What was our 180?
180 would be just pi radians.
Pi radians. What about 270? Any idea? We didn't
Would
convert
be
that. Well, if we did the conversion, I'll just show you. That comes out to 3
3/4.
pi
maybe.
over 2 radians, right? All right, so 0 pi over 2 pi, 3 pi over 2, and then all the way back around would be 2 pi radians. Okay? So it's just like what we set up in degrees, but we need to kind of know what they are in radians. Okay? If I've lost anybody, please say something. Okay? All right, is everybody able to copy this?
Mhm.
All right, let's go back and finish that example. Now that we know how to convert, okay? So now in part B, using 2 equivalent angles, we're going to convert 30 degrees into radians, what they want, right? So let's take our 30 degrees like we did on the notes page, right? And we're going to multiply it so that degrees cancel. So it's either going to be pi over 180 or 180 over pi. Which one?
Pi over 180.
So pi radians over 180 degrees, right? Our degrees cancel. So that leaves us, let's take the 30 and 180. Let's divide them both by 10 to get started, right? So would that be 3 pi over 18? Radians?
And you divide by 3 to get 1/6
Yeah.
pi radians.
Right, or just pi over 6 radians, right? Pi over 6 radians. So now we know 30 degrees is equivalent to pi over 6 radians. All right? So let's do an example. We already did 90, didn't we? Back on the other page. Okay? So we took our 90 degrees, right? Times pi radians over 180 degrees, right? We did this one. And what did we end up with?
Pi over 2.
pi over 2 radians.
radian.
Okay? Gosh, we did 120, didn't we? I'll do it again real quick. So we took our 120, and I'll let you guys try the 225. Recording, yeah. Okay, 120 degrees, right? Times pi radians over 180 degrees, right? So the degrees cancel, right? So we're left with 12 pi over 18, yeah?
Yep.
Radians,
And divide by 6.
right? That left us with 2 pi over 3 radians. Okay? So what's that one? All right, I'm going to let you guys try the 225. So we're going to take our 225 degrees and just tell me what we're going to multiply by. What over what? Because we want degrees to cancel.
Pi over radians.
Pi radians over 180 degrees. Okay, so what I want you to do is cancel out degrees and get everything in lowest terms, all right? And keep it in terms of pi. So I'd like everyone to take a minute and see if they can figure out how many radians is 225 degrees. Let's go back through that then. So we know that the degrees will cancel, right? Now, 225 and 180, if I divide 225 by 5, what do I get?
You would get
Let's
225 by,
what is that?
you get 225 pi.
What's 225 divided by 5?
You would get 45.
45, right? What did I pick? 5. I could see they're both, one ends in a 5, another 0. So 45 pi, and what's 180 divided by 5?
360.
No,
No, 36, sorry.
36, right? All right, well, let's see. 45 and 36. What goes into both of those? 9, probably. What's 45 divided by 9?
By 9 is the 5.
5 pi over
And 36 before,
4, 5 pi over 4 radians.
which radian.
All right, does anybody have a question on how to do those? Okay. Some of you might have, I don't know, maybe you saw that 225 and 180, you could divide them both by 15 to start out, but if you didn't, okay. All right, let's go the other way now. Now on the bottom, we're going to convert, these are all in radians. And I wish they had put radians here, so this should be, like they put the degree mark, but they don't put radians, right? So let's take our 5 pi over 6 radians, and we're going to multiply it by what? Because we want radians to cancel. Which of the two? Pi over 180 or 180 over pi? I want radians to cancel. Well, radians is on the top.
You would do it with 180 over radians of a pi radian.
Okay. And so radians will cancel, right? And we're left with just degrees. Well, now, all I have to do is take my calculator.
Also the pi will cancel out.
Oh, and the pi's cancel. So, yep. Forgot about that. The pi's cancel. So now I'm just left with, you could take your remember in a fraction, that 5 over 6, top means multiply, bottom means divide. On your calculator now, all you have to do is 180 times 5 divided by 6. Right? And what do you get? 180 times
150.
180 times 5 divided by 6.
150.
150 degrees. Yep.
Yep.
150 degrees. So that number of radians is 150 degrees. You guys, let's see. Oh, I'm skipping, my eyes are skipping around. All right, let's try this next one here. We've got 3 pi over 2, and again, they should put radians here so you know for sure, right? So 3 pi over 2 radians. I want radians to cancel, so I need them on the bottom, right? So 180 degrees over pi radians, right? So the pi's cancel, the radians cancel, okay? And I'll just do 180 times 3 divided by 2. Or you could do 180 divided by 2 times 3. And what do we get, guys?
270.
270 degrees. There you go. All right. Okay. And you guys try this last one on your own. These are in radians, right? So we're going to have 3 pi over 4 times our and that's radians, times some ratio. What's the ratio? Let's see what you guys get. How many degrees is that?
You would get 135 degrees.
135. Simple as that. All right. Okay. So we want units to cancel and be left with the units that we want, right? So if we want to get degrees, we need radians to cancel. If we want to get radians, we need degrees to cancel. Now in exercise 6, you notice there's no pi in here. So what they did is they have pi in the calculator, right? So these are all radian measures, right? So this first one, A, is 5.8 radians, okay? Which means we have not been putting pi, they're going for, right, in the calculator, but now they have, okay? And they want to convert this to degrees, okay? So pi now will go in the calculator. So 5.8 radians, right? Radians, what are we going to multiply by to get degrees left?
We would divide by 180 divided by over pi radians.
Right? And now
Which means
we're going to have the radians cancel, and you're going to have your pi. And so now it's just going to be 180 times 5.8 divided by, and you should have a pi button, right? Don't use your going forward, use the pi button. And how many degrees do we get here? To the nearest degree.
it would get 332 degrees.
All right? You guys able to get 332? Why is that doing that? Stupid.
Yeah.
Yeah, you had to round it, right? 332 degrees, right? So you're just putting the pi in the calculator now. Okay, you guys try these last two here, all right? Convert those and I wish they would do this, because sometimes it's not clear, right? Radians, negative 2.5 radians, all right? So I want you to convert those to degrees the way we just did it, okay? Take a moment. What do we get for B?
You would get 241.
241 degrees. Good. All right. Oh, somebody better hit their mute button. And for C?
I got negative 143.
You got it right. Negative 143 degrees. Okay? That one would be going clockwise, right? From the positive x-axis. Okay. I think you might be getting a grip on this. Let's go on to 7. Angle drawn in standard position, like we've been drawing them, right? Whose radian measure is 2 radians. Let's think about that, right? Okay, 2 radians. There's no pi in there, right? But remember, 180 degrees is how many radians, guys?
2 pi radians.
No. 180 is just pi. Right?
Yeah.
Pi radians. Now, pi is what? 3.14 roughly? Can you agree?
Yeah.
Okay. So if it's 2 radians, and you know that pi radians, 180, right? It's like 3.14. 2 radians, would that be greater than or less than 180 degrees?
Greater than.
Well, wait a minute. I thought 180 was pi, 3.14 radians. This one says 2 radians.
That means it'll just be 1.
It's less than 180, isn't it? Right? Just look. I just want you thinking about it before. So this is pi radians out here. 3.14 of them. If they're talking about 2 radians, wouldn't that have to be less than pi radians, so less than 180? All right. Well, anyway, go ahead and do the conversion. All right, 2 radians times 180 divided by pi radians, and what do we get? How many degrees? Times 2 divided by pi. What do you divide by pi times 2?
That means it'll be 57
No,
point.
no. Times 2.
Well, times 2.
Come on.
114.
Yeah, like 114.6 degrees, right? So wouldn't it be, I don't know, like out here somewhere, right? All right, so that's 2 radians, less than 3.14 radians, so less than 180. Wouldn't you see how I was thinking about that beforehand? So what quadrant are we in? Two.
Would be in a 2.
Yeah, you guys are slow to answer. Man. Let's look at these. So these are some common ones you probably should try to know, right? Like we already know the 0 and pi radians. Let me just draw a sketch. See how they have in this box here? And if you can kind of commit these to memory, it'll make your life a little easier. So you don't have to keep converting all the time, right? So 30 degrees, right? If let's draw a, I don't know, let's draw like a circle all the way around like that, right? So a 30-degree angle, that'd be about here, wouldn't it? So what was 30 degrees in terms of radians?
Pi divided by 6.
Over 6, right? And then they got like 45 would be here, right? Wouldn't it?
That'd be pi 4.
Pi over 4, and then 60 degree, I don't know, I'm way off on my thing.
That'd be pi over 3.
Over 60 is pi over 3. And we know 90, right? We did that. That's pi over
That'd be
2,
pi over 2.
right? And then it would keep going. Then they do 180. It's just pi, right? 270 here is 3 pi over 2. And 360 is 2 pi 0 or 2 pi, right? As you go around. So those would be some of the common radian angle measures as we go around. Okay. All right. So I know this is all kind of new to you guys. Does anyone have any questions on this? Kind of get the idea how to convert between radians and degrees and vice versa?